All right, so this is a talk on date and time in .NET. So isn't this a bit boring? Well, yeah, but my main motivation is I wanted to get out of the house and Kev asked me to do a talk. And I wanted free pizza. And I wanted free beer. He's not actually brought any free beer, so I thought about leaving. But secondary motivations are I want to moan about date time for a bit because it's rubbish. And then I want to go through some gotchas with date and time in .NET. So most of you will know most of this already, but it's good to have a refresher. And yeah, so we'll go through some edge cases and gotchas. And then also I can tie this into .NET 6, which is in preview now, because there's a couple of new types to do with date and time. So there's date only and time only. So I've got some boring code to look at, so I've used some cool pictures to make up for it. Let's have a look at date time. Can you see that all right? It's a bit small. I'll go for that. So I'm just going to show the one of the main issues with date time. So I'm making two date time values here. I've got DT local and DT UTC, and they're 12 noon on the same day. But for this first one, I'm specifying kind local, and the second one, specifying kind UTC. Let's run this up actually. So you can see, yeah, that's what's printed out for these two. But then I can also convert DT local into universal time using this method. And you can see, because my machine's running in ENGB culture, DT local is actually 11 AM in UTC time. So these two date times, DT local and DT UTC, refer to different points in time. So obviously .NET, if we ask them if they're equal, the only sensible answer is to say no, they're not equal. It should return false. So it returns true. And this is basically the source of all problems with date time in .NET. So the issue is that date time has this kind property, and comparison operators totally ignore it, and that can lead to all sorts of bugs. Just to make sure we're not totally mad, let's do this. We can compare DT local after I've converted it into UTC time and run this. So this is more sensible. So this gives us the right answer that they are different times. So this only works because kind is the same for this comparison. So, I mean, the upshot is if you're comparing date times, then you need to make sure that that kind is the same. It has the same value for each of the date times. The problem is it's very easy to not know what your date time kind is set to. So without specifying a kind at all here, if I run this, you'll see each one of these values has a different kind, and we've not asked. So UTC now, obviously that's in UTC kind. Date time now is set to local kind, and if you just construct a date time without specifying anything, you get unspecified. So yeah, it's easy to shoot yourself in the foot, basically. So yeah, just to recap, date time stores a date and a time, as you'd expect, and you can specify a calendar system. That's a big area of complexity that I'm not going to go into. It doesn't store an offset from UTC, and it has this kind property, as we've seen with UTC, local, or unspecified values. Now, these aren't actually dodgy. As a concept, these are fine. Every one of these kind values models a good real-world thing, so unspecified could be useful. Wake me up at 8 o'clock on a certain day, regardless of the time zone, or a chain of shops opening at 9 AM, wherever they are. But the problem is in the implementation, it's just wrong. So the alternative, as I'm sure you know, is DateTimeOffset, which is better. So DateTimeOffset uniquely and unambiguously identifies a single point in time. So you actually know what time it's referring to all the time. Unlike DateTime. And the Microsoft docs say, consider DateTimeOffset as the default date and time type for application development. So basically, in most cases, use this instead. But I do see datetime being used where it shouldn't be, or where datetime offset would be better. I wonder why, and I think it's just like the framework use it in a bunch of places. Datetime sounds the more obvious choice. If you don't care about having an offset, then datetime seems like it's the more obvious type. But in most cases, even if you don't care about an offset, datetime offset will cause you fewer problems. And how this all kind of came about is, so .NET 1 had this datetime type in there, and that didn't have the kind property on it, and all was fine. .NET 2 introduced datetime offset because it's useful to have a store a time and an offset from UTC. That's all fine. But .NET 2 also introduced datetime kind, and this is where it all went wrong. So they thought they were being helpful, but what really happened was developers were forced to specify this information or face unexpected bugs. To make matters worse, kind is inconsistently honoured, so serializers, etc., inconsistently deal with this kind property. And as we've seen, the comparison operators totally ignore kind. So let's have a look at a few more gotchas around this sort of thing. So what's this one? So this is implicit conversion, so this is a good one. So I'm making a date time value here, so 12 noon on the 29th of June, and then there's an implicit conversion that you can do. I can set a date time offset variable equal to my date time value. So what will this do? Anyone know? So it goes from being unspecified to being 12 noon plus 1 offset. Is that right? Maybe, but it's definitely unusual or unexpected. If you're not, you might not be expecting this, and it can cause issues. Another one here. So look at JSON.NET serialization. I've got this. I've got a little bit of JSON here. So I've got time and time 2 values, and these refer to 12 noon on the same day, and they both have 0 offset from UTC, but the 0 offset's expressed slightly differently. So this is +0, and this is Z, so they both mean UTC time. So what happens if I deserialize this into my foo type, which has got 2 date time properties? So what happens is it treats them differently, and foo.time comes out as 1 PM local with local kind, and time 2 comes out as 12 noon UTC kind. So is that right? Well, kind of if you read the docs, but it is still a bit weird, and it will cause you issues. And also nicely, these 2 points in time that are the same, then if you try and compare them, it will give you false, which is the wrong answer. So just to look at some good code, this is just how you use datetime offset. It's all very obvious. So we can do datetime_offset.now.utc now. We can construct a datetime offset giving it an offset value, and there's some handy methods to convert to universal time or to a different offset, and this all works as you'd expect. So this is much more sane. What's the other one? The last one, so another gotcha. This affects both datetime and datetime offset, but with this one, this is a classic one where we'll round trip a date time by using the default toString to get a string date time, and then we'll pass it back in. Oh, I've just selected that. So I've written out this date time offset as a string, and I've passed it back in, and everything's okay. So you might think, well, this is all fine then. But actually this isn't fine if different PCs are involved that might be running in different cultures. So this works because it's on the same PC and I'm running in ENGB culture. But what happens if we stringify the date time and then we pass it to another machine that happens to be running in ENUS culture? So the same parse code will this time throw an exception because there's no 30th month, and Americans put their month first. So the best way to address this is if you're going to write dates and times out of strings, always specify the invariant culture, and then also specify that again when you're passing back in. And for date time offsets, this is enough to fix the problem. For date times, it's a bit more complicated, and there's quite a lot of docs around this. The other way to do this is to use the round trip specifier rather than this invariant culture, because this uses the ISO 8601 format. What have I done wrong there? That's it. So this ISO format will round trip fine for date time offsets. It's more complicated again for date times, and you need to do something else as well there. So yeah, that's a bunch of little gotchas with it. So basically, if you use date time offset, everything should be fine. No, because of time zones. So time zones in .NET are represented by time zone info values, and time zones include daylight saving time changes. So this is something that John Skeet posted on Stack Overflow years ago. So he says, strikes me as odd there isn't a date time zone struct which has both the instant in time and its time zone, because the date time offset doesn't actually give you everything you need. So if you've got a date time offset, you don't actually know what the time will be in that in that local time 24 hours later, because you don't know if DST is going to kick in the meantime. So that's another thing to be aware of. So John Skeet said this in 2008. And in 2009, he'd started Noda Time. So you've got to mention Noda Time if you're doing a talk on .NET Date and Time. So I have done. I don't know much about it. I've never used it in anger. It's very good, very comprehensive. It's certainly worth a look if you're doing anything serious around this. But it is quite complex, and you need to use it throughout your application if you're going to get the benefits of it. And if you're writing a component, you have to kind of force this third-party dependency onto your consumers as well. So it's one to think about. So on to .NET 6. So .NET 6 has got these. It's in preview now. I think it's out in November time. Is it supposed to be? I might be right. Yeah. And it's got two nice little new types in it. So there's date only and time only, and basically, these do what you expect. So the good news is they're quite good and useful. The bad news is there's not much to demo on them. So surprisingly, we've got to this point without having these. But they should be really useful, and they're going to provide much better type safety than what people tend to do now. So if you want to represent a date only now, you'll use a date time offset and just ignore the time part. But that can cause issues if the time is sort of on the boundary of a day, and then your date starts shifting around in database queries. And these will map well to SQL Server date and time data types. So let's have a little look at these in code. So this I've got here in VS Code. So this is running .NET 6 Preview 6, and let's just run this up. Let's look at the code. It's very slow. So Steve Gordon's got a good blog on this, so you can refer to this. But I mean, it's all as you expect. So I can make a date time value and write it out, and you get what you asked for. Internally, date only is represented. It uses an integer to track a day number. So day number 0 is 1st of January, year 1. So we can write that out, and that's the day number of the 1st of July this year. You can take a date only and convert it to a date time by providing a time only component. That's fine, although it gives you a date time with kind unspecified, which is correct because you've not specified a kind, but that could potentially cause you problems as we've seen. You can take a date only or you take a date time and strip off the date to get a date only. And you can do some maths, so you can add some days, months and years, and that all works as you expect. And looking at time only, So here we go, we can make a time only. You can specify hours and minutes, or you can also specify seconds and milliseconds. And if you look at the output, by default it doesn't write out the seconds. You can take two time onlys away, so one away from the other, you get a time span. You can strip off the time from a date time, and there's also a handy is between method, so we can say is the time now between T1 and T2, and it is in this case. So yeah, all kind of nice and useful. And that's basically it. So to summarise, use DateTimeOffset in most cases. Be suspicious if you see date time. Think if it's really the right thing to use. Consider storing dates and times in UTC. There's less confusion that way. Also store time zone info if you need to do. If you are going to use date time, always check kind before comparing anything. And be very paranoid testing and reviewing serialization and database conversions, because you will have problems. And yeah, for .NET 6 then consider these new types, because they should be good. And that's it. So I'll leave you with this picture. So if you think of date time as kind of a surrealist work of art rather than a rational coding choice, then that's what I'm going to leave you with. Thank you.